Recording. Hello everyone. Hello. I didn't expect this much people today. Abi Mbola, Morba, Darkness, Nangasi, Harp, Mitsiti, Jealous, Jonja, Joyol, Kalwaiti, Coach, Minatalla, Mina Midhat, Mambi, Motasm, Ricky, Rokia, Somzi. Hello everyone. Today we're gonna do this 3 LeetCode. So we have key closed point, origin, longest substring, and maximum subarray. This is why we couldn't do it the previous session, so we move it here, and the one that was here I move it to the last day because we have only 10 for this week. So we're gonna start with this maximum subarray. Let's see what it is about. And because I noticed this medium problems, they take a lot of time to like think. So we're gonna try to brainstorm in like a short time, so we don't expand. And then I can, because I did them already, I can just pitch the idea, or if we didn't find something like better. So like this, we can keep the time short. Okay, so let's jump to what was the week 7 maximum subarray, this one. Okay, let's see the problem. So given an integer array nums, find the subarray with the largest sum and return its sum. Given an integer array nums, okay, here is it. Find the subarray with the largest sum and return its sum. So this is the array. Let's take it to, and by the way, there is algorithm for this problem called Kadan algorithm. I will post it here just if someone want to check it out. Will help us with this problem. And let's take this to the lab, see what they mean. And okay, you know that problem that was annoying me is like if I click like this, I can't click here, right? I create a script to toggle this so I can hide it, then I can click here. Now I feel so free, finally.
That's nice.
Wait.
I did send the Excalibur support. They say no, you don't have, you can use this way, but this one it disappeared, right? So I told them it's okay, and they create this script. Sometimes you just need to create solution for yourself. Okay, let's go back to the problem.
Send to them, bro. They pay you for that.
I was gonna send them. I was like gonna send them a moment when it was so hard, because like, why this gonna take all this space? There is no reason. Like I choose the color, then I wanna write here. It should be like a button to like push it to the side or something. Anyway.
Yeah, send that thing to them, man. They should pay you for that extension.
Okay, so maximum subarray. So we have the first array, which is this one. Let's try to see the problem, how the problem works. So we have -2, 1, -3, 4. Let me zoom. -2, 1, -3, 4, -1, 2, 1, -5, 4, and somehow we need to like give the largest sum and return its sum. So we need to find the largest sum here and return it. find this subarray with largest sum. So in here they say 6. Let's see how did they find out about that. So 6, so they did -2 plus 1. -2 plus 1, what is that? 1. So this give 1. Then 1 plus -3, right? So this give 1. Then the total of this with this, what is that? 1 plus -3 is -2. And then I'm not sure, maybe they calculate like
Wait.
this.
No. It's -2 plus 1 would give you -1. And then -3 will give you -1, -3 will give you -4. And then it becomes 0. And then it becomes it basically you're taking the summation as you go through each element. So they're looking for the subarray, right? The longest string you can get to get you the highest value.
Okay, maybe I misunderstand, because I thought.
Are you using the sum of the first array and the second array, or they're separate? I think they're supposed to be separate.
No, those are two separate arrays. What you're supposed to do is find the longest sequential, the series of elements that will get you the largest sum.
But like I've heard you say -1 minus 8. Negative.
No, I was just doing it from the beginning, because at the beginning, remember, he did -2 and then the 1. So I was just saying -2 plus 1 will give you -1, right?
Yeah, and then the second array should be 1 plus -3.
Wait, there's something you said, guys. Second array. There is only one array here. There's no second array.
Subarray.
Oh. Okay.
The only reason I was doing it like that is because you don't know what the next element is going to be. So my assumption is that you're going to have to calculate it as you go. I haven't looked at that algorithm that Winsif shared, but from my understanding of the question, it would mean that essentially -2, and then the 1, you'd have to sum them, right? That the result of that would be -1. And then if you were to go on, if the starting point is the 0th index, you would have to keep on going, right, until you figure out exactly how much the sum of that particular index would give you if you start at the 0 index and you keep on going.
So in your next sum, what will be the subarray?
Wait, I'm confused. We're not gonna return the subarray.
Yeah.
We just gonna return the total 6. So like we can just go, like if we did brute force, can we just like do plus and then we're gonna find 6?
Okay.
That wouldn't be 6, because once you're done with it, I think it'll be a negative number. The subarray that you'd find, depending on the algorithm that we use, that'll give you the maximum or the largest, would be the one that starts at the 4th, where the 4 starts, so at the 0, 1, 2, 3, the third index of the array, and then you go all the way up until the 1. So you just go 4 numbers, and then that'll give you the maximum sum that you can possibly get from this, this array.
Okay, you wanna guide me, because I still didn't understand. I feel like you can split the problem to like parts.
Okay.
Yes, go ahead.
Yagase, right?
Yes, sir.
Yes. So what you're saying in essence is you keep adding all the elements until you get a math. So how will that work now? So are you going to just add each element? Okay, say I add the first element with the second element, and I get the number, then I add with the third element. I'm trying to like imagine how that will be, because in this case now we have 4 elements that makes the subarray that gives us the highest value.
Yes.
Oh, okay, see. I thought we're gonna add them all. But we are
No.
looking on which one of them that is when we add it or we do some of it, it gives us the big number.
The
Yes.
biggest number, yes.
Okay, now I
Um,
see it.
It might be the case where it's all of them will give you the biggest number. Sometimes, because you know how subarrays work, but it won't always be the case. So we now have to figure out an algorithm that's going to allow us to find the maximum subarray.
I was thinking of sliding window too.
Sliding window can work. We can also apply this one because this one is kinda made for this problem. Given an array R of size n, the task is to find the sum of the contiguous subarray within an array with the largest sum. Okay, array minus 4 minus, and then it gives 7. For this, how this work? The idea of Cadence algorithm is to maintain a variable max and then here that store the maximum sum contiguous subarray and then at current index, and a variable max so far store the maximum sum of contiguous subarray found so far. Every time there is a positive sum value in max and then here, compare it with the max so far and update max so far if it's greater than the max so far. Okay, if understand what they're saying is like we're gonna be moving through this array and we are doing sum and we have a variable that have we're gonna keep track of the sum. So let's say we reach here and we have 5 and we are going and we reach here and the value, let's say it's dropped by -5. We're not gonna update this, we're gonna keep this as the largest. But if we reach here and it's become like plus like 11, it's gonna be, we're gonna update it. So like we are looping through the array and we are adding this together and we see if it is larger than the sum that we already have, we're gonna update. If not, we're not. Every time there is a positive sum value in max and in here, compare it with max so far and update max so far if it is greater than max so far. Okay, let's see an example. Pseudocode. Max so far, max and in here, loop for each element of the array. Max and in here, max and in here plus AI. Okay, so the element we are looping through, but what's the value of max and in here is 0. So at the start we have 0. There is nothing in sum. So we're gonna add that element to the max ending, and then if the max so far is int mean, what that mean? Int mean is like the max or like the at least or like the most negative number.
Yes, least negative.
Okay. I don't know why they did that. Why not? Or maybe because they're gonna compare it or something. Let's see.
You know, some of the values will be negative, so you have to use the very last negative.
Yeah. Okay, so because let's say this is 0, we have positive, negative. We can't put it in 0 because we may have negative number. So what they did is they put it in like the last or like the least negative number. Kinda how I understand it. And they check if max so far is less than the end in here, we're gonna update max so far. Okay. Else we're not gonna update, but we're gonna do if max end in here is less than positive, we're gonna reset to 0. Okay, that's a cool note. Like if, but max ending here. So if we did at some point, we're moving through this, let's say we're moving through this loop, and we reach here, and we did and here it was 4, right? And this number was -10, and we did -10 plus, is that max ending here, max ending here. Confusing a bit, but that's like something. If you did -4 plus 4, it's gonna be less than 0. So they are using two variables. Max ending here. You know what? Let's take this here and try to understand it. Wait, someone did write. Okay, give me a second. Okay, so we said like, let's take this. Oh, someone did explain it here. Cardan algorithm is used to find the maximum sum subarray within the given array of integer. Here, detailed explanation. Okay, let's maybe copy it here to see it well. Okay, we have max current, then you loop on the array, max current, and the max global. Max global is probably the max so far, and max ending here is the max current, and they keep updating the max current by the max. Okay, let's try to understand. Okay, someone did some solution, I think. Oh, okay, we're gonna come back to this later and see, we compare and see how you did it. Okay, now let's take this algorithm, try to do it with this algorithm. Okay, how we can do this? Okay, let's apply this algorithm to this code. Okay, so we have max so far, here is it, max SF so far, and the max ending, which is max ending
MEH. Yeah.
And we're gonna see how this algorithm works. So we have loop for each element. Okay, let's say this is the pointer that looping. We have -2, max ending here, which is this one. It's gonna be equal to, by the way, this one is 0, and this one, let's say infinite, minus infinite, minus e. Max ending here, it's gonna be equal to max ending here plus e IE, which is -2. So -2 plus 0 is gonna be max ending here. It's gonna be -2. Okay, here is it. minus 2. Let's keep it like this. Say okay, here's the update minus 2. Then after that we're gonna do if max so far, which is 0, is less than the max ending. Okay, not 0, sorry, infinite number, like the least negative number. If it is less than the max ending, then update the max so far. In our case it is true, so max so far gonna be equal to minus 2. Please, if someone did understand or I did go fast on some 10, just open mic, ask question or write in the chat. Then after we update the max so far, if max ending here is less than 0, put max ending here 0. So our max ending here is minus 2, so we're gonna reset it to 0, and then this is gonna stay minus 2. Okay, now why did it this minus 0? I think it explains it here. I think because if we are going like this and we have minus 2, why did it reset to 0? I think it's in my mind, but
it doesn't necessarily reset to 0. It resets to the current index you're pointing at. So essentially, you can imagine yourself stacking up money, right? And then you get to a point where the next month, if you look at each one as like money, if you get to a point where the next month makes more money than the progressive months before you combined, it would mean that this is probably the place that you want to start, because this is the new height. So you want to just go ahead and forget everything before you, because it's going to leave you at a deficit, and you want to go with the point that you're at currently, because that's the new relative, you know what I mean? Everything before it is smaller than at the point that you're at currently. So you can just abandon everything before you and then go start from the current index that you're at and then move forward again. And then you keep on doing that until you get to the point where you accumulate, or at least they get to the point where you're at the end of the array. And when you get to the end of the array, using that same logic, you would have essentially calculated the maximum you could have made in those progressive months, or at least the streak of months, if that makes sense.
Okay, now I see it. So it's like you saying, if I am looking for the maximum sum, and if I have already here minus 2, I can just start from 0, because whatever I'm gonna add here gonna be still greater, right? Did I understand well? Because it will not affect the the maximum sum. Right? Or no?
I guess maybe think of it as negatives are useless, so it will not add to the max, so you just like discard it after you compare.
But is it gonna affect the result of the max so far? I don't think so. Okay, maybe it will be clear for me when we're gonna like finish looping through the array. Okay, let's continue. So what they did here, if the max ending here is less than 0, just set it to 0. when do we use max end in here? We use it here to compare max so far less than max end in here. Then we update max and then max so far. Okay, it's still a bit confusing for me. Let's go to the second number. Let's say we reset it to 0, then we go to 1. What's gonna happen? So when it go to 1, we're gonna do max end in here, which is this one. It's gonna become max end in here plus 1. Max end in here plus 1. Now if we didn't reset this to 0, it's gonna be minus 2. So this 1, it's not gonna be 1, it's gonna be minus 2 plus 1, it's gonna be minus 1. Okay, let me do it like this, see what's gonna happen if we didn't do this. And now we're gonna go if max so far, which is this one, is less than max end in here, which is 1, we're gonna update max so far with max end in here. So we're gonna update this if max so far is less than max end in here. In our case, max so far is minus 2, and minus 2 is less than 1, and same time is less than minus 1. So it's gonna be updated. So in this case it's gonna become 1 because we're following this. And then we're gonna see if max and then is less than 0. If max and then here is less than 0. In our case it's not, so we're gonna loop again. Minus 3. Okay, minus 3, what's gonna happen? We're gonna do again max and then here, which is this one, equal max and then here plus minus 3. Okay, max and then here, which is this one, sorry. So this one, 1 plus minus 3. Is that minus 2? Minus 2, right?
Yes.
And then, so this is gonna be minus 2. And then we're gonna check if max so far, which is 1, is less than max in the here. Is max so far is less than max in the here. In our case, it's not, because max so far is greater than max in the here. Now, if max in the here is less than 0, we're gonna reset it to 0. Okay, and then we're gonna loop. When we're gonna loop, this can still be 1. Now if we didn't reset to 0, it's gonna be minus 2 here. Okay, we are trying to understand this algorithm. Then we're gonna go to 4, and in 4 we're gonna do the same, max and then here. We're gonna update max and then here, which is gonna be 0 plus 4. 0 plus 4 is 4. If we didn't reset to 0, it's gonna be 0. It's gonna be minus 2 plus 4, which means minus It's mean 2. Wait, it's gonna be 4
Yeah, it's 2. 4
minus
plus
2 plus 4. Okay, it's gonna be 2.
Hmm.
Okay, and then we're gonna jump. If max so far, which is 1, is less than max, and then here we're gonna update. It is less, so we're gonna update it to 4. Because max so far is 1, but max under here is greater, and we are looking for the greater sum. So we need to update this one by 4. And then we're gonna check if max end in here is less than 0. It's not, so we're gonna loop again. Okay, I already see some why we reset to 0, because it actually doesn't matter. Like it's like I don't know, I can't find the word to describe, but hopefully when we finished it will be clear. Okay, so 4 we loop to -1. We loop to -1. We did max end in here. We're gonna update max end in here by 4 plus -1. So it's gonna be 3. And after we update max end here, we check if we need to update the so far. In our case, 4 is already greater than 3, so there is no need to update it. And then I'm gonna check, is 3 is less than 0? No. Okay, then I'm gonna do this. Okay. Then this gonna be 3. This gonna stay 4.
Yes.
Then we're gonna move to a new number. We're gonna ask same question. What is the max currently in this moment? Is gonna be 2 plus what I do have here, which is 3, so 5. And then I'm gonna compare. Do I need to update max so far? Yes, because 5 is greater than 4. Okay, 5. Then we're gonna loop again. Okay, we were in 1, right? 2, 3.
5 plus 1, yeah? Max ending here is 5 plus 1 at that point.
So 6. So it's gonna be 6. So 5 plus 1, 6. Do I need to update? Yes. 6. 6 again. Loop. And here we're gonna have -5. -5 plus 6 is gonna be 1. 1, do I have to update? No, so I'm gonna keep it 6. And here it's gonna be 1. And then 4. 4 plus 1 is 5. Do I need to update 6? No. So it's gonna stay 6. And there it's gonna stay 5. And by this we actually got the number 6, which is the higher sum we have. Okay, I see the flow now after we did it step by step. I also see why this doesn't matter, because the goal from the max end in here is to compare at the end with the max so far. So when we compared, it didn't make any difference. I think that's how I didn't understand. I'm sure someone have better way to describe it. But what I noticed is like it doesn't affect the results that we're looking for. We still gonna, but what if we didn't reset to 0? I think it will still work.
There was a question asked, what happens if they're all negative numbers?
Oh, I didn't see chat. So what if it was all negative number?
Yeah, I think Mina asked that number. I mean that question, sorry.
Maybe the limit
It was
is
a
here.
comment. I know it works.
It
was a
will
comment.
work.
Solution in the sheet.
This one.
This is my solution without resetting.
Okay, so this current sum and max sum. So you did the same algorithm, I think?
It's the
Or
same
not?
without resetting to 0. I initialize both of them, the first element of the array.
Okay, so this one too from Sabah. Okay, so how this one work? Is it the same thing? So you create max sum and you give it infinity, which is kind of the same technique here, and then current sum is 0. So I believe this current sum is max and then here, and then you loop through each element in the array, and the current sum which in our case is this one, this here, is gonna be the max of the current sum with the number. The max. Yeah, I think, wait, max of current sum, no, current sum plus number and number itself. Oh, okay. So this is the minus 0.10 probably. It's kinda the same, because when you do max of the current sum and the number, so if the number is greater, so let's say the current sum is minus 2 and your number is maybe 1, so
Can I
you're gonna
comment
do
on something? Someone is
can you repeat?
maximum sum is updated first. So if resetting
I think your
0
voice cutting off, probably network problem.
didn't conflict with the
We can't
result.
hear you.
Because max negative, if it has a negative value, it will work at the end.
Okay, maybe you can try to write it. Okay, so what I was mentioning is this max right here. It's kinda working as this reset 0 here. I think I could be wrong. Let me see. So if we have like 1 and minus 2, and we have like here minus 2 and here 1, it's gonna ignore the because 1 and minus 2 is gonna be minus 1, right? So it's gonna compare minus 1 with num. So it's gonna compare minus 1 with 1, and it's gonna take the bigger one here, and that's what's gonna put in the current sum. It is like if we put minus 2 to 0 and we did 1 plus 0, and compare 1 with 1 plus 0, which is 1 1 1. Okay, so this is cool. What else? In the max sum, yeah, the max sum is you're gonna check this with this, if which one is bigger, like current sum or max sum. I hope I didn't confuse someone. Please, if you have question, just go ahead. I'm sure someone here can answer, or I do my best to answer it. This one work with the pointer, I think. To pointer? No, to pointer. You loop through element if the number. Okay, so this is the same, yeah. So sum, you compare them. If it is, you update current. If not, you add it. Oh, so this is the max here. So this 3 line is 1 line here. And then the max sum. Okay, genius, guys. Now the last solution we saw of the coach is you're gonna loop through the element. You update the sum to 0 if it is negative. Okay, the same thing we saw. And then you update the sum plus a, yeah, because the number. So you add that to sum. Wait, you add it directly to sum? Sum and the result. Oh, okay, so sum is current sum for you, and the result is the max sum. Okay, it makes sense now. Okay, they are all of them the same same principle, or like same way, but it doesn't matter which language you code solution. If you understand this algorithm and you did something like this, you can code this then with any language, right? I think this is the faster way to code it. Let's try this code. Okay. Let's run. Submit. See how much performance. 41. Let's see this one. How much performance? $24. I guess something here was slowing. Maybe the max, 2 max, or maybe this float. That's why. Okay, I hope this LeetCode is clear. Like the solution is clear. If there's no question, we can jump to the next one.
If, for example, you are required to return the subarray, how would we have gone about it?
You're probably gonna create a new array and start adding numbers to them when the sum is great. Maybe you can keep track.
Yeah, you'd have to check when the maximum is changed to the current array. In the RI thing is greater than the max underscore current plus array I, and then also you'd have to check when the max global or whatever is changed as well. Yeah, you'd have to check the indexes and track them. But it's doable. It's doable.
Okay.
Where is this second LeetCode link? Give me a second. Where are you? Looking for you. Or maybe someone have it. Wait. What I'm doing? I think I need to go sleep. It is right here. Okay, so we can start with the longest substring or this one. This one we did it already kinda with the hip, but not same one. What you guys wanna do? This one first? We're gonna do them both, so just which one you prefer first? The dinner or dessert? We can do this one with hip. Okay, let's jump to it. Let me write the link in the chat if someone wanna get out. So we have key closed point to origin. Give an array of points where point e, x, y represent a point on the xy plane, and an integer k return the k closed point to the origin. The distance between 2 points on the xy plane is the Euclidean distance. Okay. You may return the answer in any order. The answer is guaranteed to be unique, except for the order that it is in. Okay, let me read it again. Given an array of points, where is it? Okay, this one. Okay, let's take it there because we can read it. And
This is gonna require a bit of math. Do you guys remember how to track the distance in a Cartesian coordinate way?
I mean, you can ask ChatGPT. Or if someone
Yeah, it's that Euclidean algorithm.
Wait, what was the distance between what and what?
The Euclidean distance.
2 points?
Yeah, we need to
0. So between the... Okay, so given an array... Okay, before we jump to this...
Oh, it's written there. It's written right there. We get the square root of x1 minus x2 squared plus y1 minus y2 squared. I think the x1 and the y1 are always 0, if I'm not mistaken.
I have no idea.
Yeah, the origin is 0, 0.
Okay, so this is the 2 points, right? And from what I understand, we are looking to see which one is close to 0.
The 0, 0 point, the dead center.
Is this one or this one? Which one is close? Is the 3 one, right?
No. I don't think you can do it that way. You have to kind of punch in the numbers.
No. I'm just like with the visual like looking, but I don't know. I think this one close to the 0, because if you can feel this is longer than this. Like if you compare this with this, right? So this one is the close to 0. But
Yeah, it looks like it.
But we need to do it with the math. Let's see. So given an array of points where point... Okay, this is our array. Our coach, your mic is open. You want to say something? Because I hear you... I hear you...
No, I think I just switched devices, so I have the idea.
Yeah, please go ahead.
Oh,
I'm just
because it's
working on
0
it
as
right
well.
now. Just give me a
Oh,
minute.
okay. So,
Because it's 0, 0 as well, I think it'll be really easy now that I think about it. Because you're squaring the numbers, right? You just take whatever numbers you have from the coordinates. So you do a 1 squared plus 3 squared, and then you get the square root of that number. And then you figure out which one of those, between all of the ones in the array, are the lowest. So essentially you get the square roots and then order them, and then you get the k nearest one. So you just have to slice the array. So
I think if you just get the power like x square minus y square, you don't need to get the power of it, the power of 2. You don't need that to be square root, I guess. Like you don't
Why?
if you only need x square and y square, because the other one is 0 and 0.
0.
Yeah, so
So
if
like this one does not
Yeah.
exist.
so
No, it's 0, so it will always, because it's a square root, right? Regardless of the fact that it's negative or positive, the outcome will always be positive, I believe.
yeah,
If there's just one number.
that
Okay. So we only
Basic-
need to check the distance. We only need this.
Yeah, essentially, I think what you need to do, it's almost like a map. You do the x, as you've done right there, and then you get the square root of the numbers, and then after that, you would have to order them, I believe. So maybe you do a tuple and then order it by the Euclidean value, and then once you've sorted them,
Wait,
you just
why
get a
order them?
slice. So you get the nearest ones, right? So the nearest ones would need to be in order.
But
of-
here they say you may return the answer in any order. The answer is guaranteed to be unique, except for the order that is in it. So let's say we find one element close to 0 or 2. It's gonna be fine if they are not in order.
I suppose, but how would we be able to track them is my question. But I hear what you're saying.
Okay, I wanna just ask, is someone here still didn't understand the problem? So like you can guys catch up with us. If I summarize the problem is like they give us array. This array have coordinates, like this coordinates 1, 3, -2. These coordinates are points in this graph, and they are like asking us like, let's say this coordinates, and they're saying which one is the closest to 0. So the idea is we're gonna check the distance, right, between the 0 and the least distance is the one close to 0, so we're gonna return this. So this is the idea of problem. But okay, so we have k. Okay, I forgot. So there is k. That means if k is 1, we're gonna return the least one that is close to 0. But if k is 2, we're gonna return 2 value. So we're gonna return this one and the one above it, this one. I guess if there is say 4, we're gonna return all of them. And the order doesn't matter, even if they are not ordered. So we have this k. If we go back here, given array of points where point represents point on the plan and an integer k, return the k close point. I completely forgot about the k. Okay, please, if you have question, go ahead. Let's continue. Ningas, you were gonna say something. You're gonna say something?
Oh no, my logic is simple. You basically map. It's essentially the map, right? So you calculate the Euclidean values for all the Cartesian points in the array. And then once you have an array, you could obviously put the values in some kind of tuple, right? Where the first element is the coordinates, and then the second element is the Euclidean value. And then and this might be unnecessary, but then if you sort the array based on the Euclidean value, then you'd get essentially the nearest ones because it's all sorted from in descending order or ascending order. I don't know which one it is, but you'd get essentially all of them in a row. So if you're then supposed to return k amounts of things, you could just get a slice of that array and then sort of kind of map them again, where you store just the values of the coordinates now into the array that would be outputted. That would be an n of, I think, maybe 3n.
I don't think they gave some constraint or something. So let me put this problem here. So for example, if we have this array, we're gonna create like tuple for each of them. It's gonna be like x, y, and distance, or like maybe distance.
Euclidean value, yeah, but yeah, the distance to origin.
Sorry, what if we just use the element itself instead of xy?
Element, but
So
the
like
element
for
is
every-
xy.
For every element that you find the distance, the first element of the tuple element that you used, that list that has the 2 points.
Yeah, that's what I meant to say. That the first element won't be x comma y, it'll be the array of xy. If that makes sense.
So you can just return that after you check all the distances if one is the smallest. So
Okay, I'm not
here comes the
following.
sorting.
The first one gonna be just the
Okay.
array,
Yeah, the
So
coordinate,
for
right?
example,
like 3 and 3.
what he's
What's
trying
gonna
to
happen?
say, like for example, if you want to calculate 3 and 3,
Yes.
and you want to calculate the distance from the origin, we'll
Yes.
get a value. So we will now put this array as it is, 3 and 3 as it is, into the tuple. Then the next element that will be
Wait, we're gonna
one.
put it in
There will
tuple.
now
So
be a
3,
distance value.
3, and distance, right? The 3
Yes.
power
but
of 2
3 and 3 will
plus.
be in an array of its own.
So we're gonna put the value here in the tuple, distance.
Yes.
Okay,
Yes.
distance. And then we're gonna put this tuple somewhere.
And that will be that will be one of the solutions for each of the arrays.
But where are we gonna put this tuple? Are we gonna put it somewhere?
I can put it in the list.
List. Okay, I'm just trying
I'll
to
put it in
understand
list.
because I didn't understand what you meant. Okay, let's say we are looping through this and we create the first tuple, we put it on the list, then we calculate this one, create the tuple, put it here, we calculate this one, create tuple, we put it here. Now each tuple have distance, but we need to return
Yes.
the list one. So it's like we're gonna
Yes, so
loop again on this list or
So we
something.
now sort by distance.
Sorts the
So if you
list
sort
by
by
distance.
distance,
Yeah.
yes. Like
Yeah.
for each of the tuples, you sort by the distance value. So it will now give you the lowest at the beginning, then the highest at the end.
Okay.
So it's easier to just pick the list.
Okay. I see it now. Is that what you meant, Ningashi? I think it's the same, right?
Yeah, but we'd then have to transform it from a tuple form back into its coordinate form. So
Oh.
instead of that, we could also add perhaps an index to make our life easier. I don't know how we'll do it, but essentially it's
Can we do it
calculate.
array of 3?
Can
Elements?
we even make it a dictionary so when you return like the keys or the values?
Yeah, I also think a dictionary would be a bit easy.
With dictionary, we're gonna do x, y, distance, right? Something like this?
Not really. Maybe XY could be the key and the distance would be the value. So it would be easier to separate the keys from the value when we want to return
So
it.
3 distance, 3 distance.
No, like
No, I
three,
think
three,
she
and then
means the point itself, like a sort of array. X, Y is the key,
array
and then
3,
the
3,
value is
and then the yeah.
distance.
Its
Okay,
distance is the
only one talk, please.
Yes, that you have that dictionary, then the key is the array.
The key is
Like,
the array, so this gonna be
like,
array,
Yes,
and
X, Y.
inside it 3, 3.
Yeah, exactly. And then the value is
Okay, and then distance. Okay. And
So now when you want to return it, you can just select the dictionary.keys and it would return just the keys after we order the dictionary.
we're gonna do dictionary.keys. Which keys is this one? We're gonna return this. Wait, I'm confused.
Yeah, so after we get the distances and we sort the dictionary and we slice it.
Oh,
So
we
to
sort the
return
dictionary
only the
on the
keys.
value.
Yeah, so we want to disregard the value.
Okay, I see. So this solution to solve the sorting problem?
No, just to return. I guess the sorting has to be done on its own.
Okay. If we put them all here without any sort, we can sort the dictionary, and then the list one gonna be the first one in dictionary. I don't know if we can access that. We can, right? We can access no, we can't. How we can access the list element here?
We need to use collections if we want to sort a dictionary.
Collections. Okay, I'm gonna just suggest one thing is the heap. If we use the heap, think about the heap is like a stack, an array, and you can put elements as much as you want. Put 5, put 3, put 2, put 1. But if you did pop, automatically it's gonna return the list number.
Then we just pop it k times.
Yeah. Now if you are using min heap, if you are using max heap, wait, maybe I flipped them. So there is two type of heap. We did them actually in the PLD of heap. This one, if you wanna come back to it, it's really useful, this heap thing. I think this will help us a lot because we can just put values and then just pop, and the first one it's gonna be the list, the list number or list distance.
Understood.
Let's work on this one. Too much writing. Let me see. But it's gonna be the same logic. It just so the heap is gonna be just a way to store. So let's write pseudocode. Please, if you have any question, don't be shy. We are all learning here. So we're gonna create the heap. Heap. I don't remember how to create a heap. Okay, so let's call it variable heap. It's a stack to array. So it's normal array, but to deal with this array, we're gonna call a module in Python called heapq, which have like push and have pop. Have like push and pop that will help us get the number we want. Okay, so here is it. We create the heap. Now let's continue our logic. Let's forget completely about the heap. Just try to continue the same logic we were working on. We said we're gonna loop on the array and calculate each one distance. Okay, so it's gonna be a loop. I'm not sure if we're gonna need like index or not. Let's just okay. So
For I in
four, right? I in what they call this one?
array.
Points.
Points. Yeah, my bad.
So let's call this points. Makes sense. So points in points. And now we have tree. So we said we're gonna create a tuple or a dictionary. Maybe a tuple is simple.
Tuple feels simple.
Yeah, because we're gonna push, because we are pushing in this array. So tuple gonna be distance. Let's call it just dist. Now we wanna calculate this point distance. We say this formula, right?
Use Subarray's equation in chat.
Okay, this is perfect. But wait, x
would be
the points
0.
are 2, so points gonna give us x and y, right?
Yes, 0.
Okay, so x, because these points have array of 2 elements inside. I think we need to count this. We don't need to count the square root. x2 is enough for sort. So we don't need to do the squared here.
That's not the Euclidean value though.
Okay, maybe you wanna elaborate, Midat? Why we don't need this?
If
It makes sense.
the square root wouldn't change.
So you're saying x2 plus y2 is gonna be the same distance as x2 plus
It'll
y2?
be the magnitude will be essentially the same. So
Oh, okay, because we're gonna compare them the same with the same formula. Okay, I see.
It satisfy the equation you're supposed to use, the Euclidean stuff.
Okay, but
it
I'm
might
sure,
be quicker.
Yeah, but I'm sure Sabah did so much math to do this, so we're gonna use it anyway. So we have distance now. The idea was to save distance in tuple. So
you do heap push, heap, and then our tuple.
Push, and then we're gonna push. What we're gonna push? X, or like tuple x, y, like we did here, and we have distance. Dist. Now inside this heap we have this tuple. So we're gonna just keep looping and pushing this element. Now there's one problem. The k. Now our heap should not have more than 2 elements in this case if we have k2, because when we're gonna return the heap it should have 2 elements. So if we keep looping on all the number calculating difference distance and we push like this, it's not gonna work. But the push, we have to push, but we need a way. Now we're gonna push this element, push, push, but we need a we need a way. It's like we're gonna pop the element. Let's say we push this one and we push this one. Now we know this is the limit 2. If we reach the limit 2, when we're gonna push this element, we're gonna say to the heap, hey, compare this element that I'm gonna push to you. If it is the least one between these two, push it. If it is not the least one between these two, don't push it, right? Because why I'm gonna push it if these two that are already there are already the least element?
So the K2 means what exactly?
So if they give us a array of 10 elements, and right, and they say find me 2 closest element to the 0, so we need to return 2 elements from the 10 point, right? If they write
Okay.
1, we're gonna return 1. Now this part's may be confusing. Who did not understand it, I can repeat this. So the problem is, like, if we keep pushing all these elements inside the heap, when we're gonna return the heap, we're gonna have like what, 3 elements, but we only need to return 2 to the closest one to the 0. So we know that the heap have this feature that if we use pop, it's gonna pop the least element. If we are using main heap or max heap. Okay, so there's 2. Let's check it out. Heap type. Main heap for short. So main heap, max heap, main heap, the smallest element at the root. Okay, so the main heap is gonna be smallest element at the root, and when we pop, it's gonna pop this one. The max heap is gonna be the big element or the greater element at the root. So we need to use main heap. So because we're gonna pop this, but okay, this a bit complicated to explain. Think of it, we put all the points that we have, right? So in this case we have only 2, so we have like this 2, and let's say this is 5, this is 2, and we're gonna add distance 1. Distance, we're gonna add it to this 3, but this 3 we want to keep it at we wanna keep it at 2 elements every time. So what I'm gonna do is I'm gonna pop one, like I'm gonna maybe compare. No, if we need to compare. Okay. So if I pop one element from here, it's gonna give me the great element, and then I can push this one.
Like if they're getting inserted in order, then you can just insert it, and then if it exceeds the length of k, then just pop.
Oh, okay, the genius. So what we're gonna do is we're gonna push it. So it's gonna, like he said, it's gonna keep the order. So somehow, let's do it like this. It's it. Okay, we said 2, 5, right? So 5, 2, and then I'm gonna add 1. to it. I'm gonna push it first. Push it. It's gonna be 1. Then I'm gonna pop, and because this is, in our case, we're gonna do implement max heap. Every time we pop, it's gonna pop the greater element, so it's gonna pop 5, right? This way I kept 2 elements and I'm sure they are the least element. Let's say I did push 10. I push 10, here's it, and then I'm gonna pop. Why I did pop? Because it exceeds the limit. I only need to leave 2. When I'm gonna pop, which one element's gonna remove? It's gonna remove 10. This way again, I kept the 2 least elements. Okay, is that clear? I know it's hard to. It's not hard. I just did. I didn't explain it well. But the idea is, if you are using heap, you can use min heap and max heap. For example, if this is max heap and this is min heap, 2 1 5, 2 1 5. If I did pop here, it's gonna return the max element, which is 5. If I did return here in min, it's gonna return 1. So this is the difference between the heap in the mode min and the mode max. In our case, we're gonna use the max because I'm gonna keep pushing the numbers and removing the bigger one. So I can just keep pushing and removing the bigger one. This way I can always keep 2 elements. Okay, let's see how we can do this in code. I hope the philosophy or the idea is clear. So in the code, now the problem is, in the heap in Python there is no max heap. There is only min heap, but there is a trick to use the min heap as a max heap. We did go all through this in the heap PLD. Is like, what you're gonna do is the distance gonna make it negative. So we said, if we did the same example before, we said 5 2 1. This is min heap, which means if I pop, it's gonna return 1, right? But notice if I flip everything to minus, which one is the min here? The 5, right? So I can pop 5, and this way I got the max number out, and then I can just flip the, just do minus, and then it's gonna become plus. Okay, if no one have question, we can continue. Now we did the minus. Now the distance is flip. Now I can keep push it. But I need to check the k. So I need to check the length. Right, because I need to pop. If the length is exceed, I need to pop, right? So I'm gonna push it, and maybe I'm gonna check if the length of heap is greater or equal. So if they say I need 2 elements, it's okay to be 2 elements. So if it's greater than k, so if it's greater than k, I will pop.
That is less than.
Can you repeat?
That is less than sign. Greater is the other way.
Sorry. Yep. So if it is greater, that means I have 3 elements. I have 5 and 2 and 1. So I need to kill 5. So let's kill it. How do we kill in Python? With pop. So heap dot kill dot How do we pop in hip? Pop. I think just pop. Hip pop. Hip hop. Oh, hip hop.
Let's start a record label.
What? Hip hop, right?
Hip hop Jonah.
Oh, hip hop. Okay, okay. I just got. Okay, so it is hip hop right here. So hip hop. So hip hop, and then we wanna. So this gonna return the bigger number. We actually don't care about this number, right? We just wanna remove it. So we don't need to save it in any variable. Now we remove this, and then we're gonna loop again. We're gonna calculate distance for this new number. Here is it, and then we're gonna push it to the hip, and then we're gonna check if it exceeds the limit. We're gonna pop this, and we're gonna keep going until the end. And the end, we are sure we have only k element, which 2 elements. Then we're gonna return this. Return hip. Did we forget something? This is look easy than it is. Maybe the hip this did a lot of work for us. Wait, push. Maybe the push, there is no push, I think. Hip push. So to push in the hip, you need to use function hip push. So here imports the model hip q. Now we push this here. Does it is it clear? Let's do a simulation. Simulation always show the problem in the code. So we have point, which is this one, point and point. We calculate the distance of that point. The point distance gonna be added in distance, and then we're gonna go to the hip. Let's say this is our hip, and we push x, y distance. So x, y distance, and then we check if the length of hip exceed k, we're gonna hip hop. In this case didn't, so we're gonna loop again. Then we're gonna add this element, and then we're gonna check, did it exceed? Yes. No, it didn't. Wait, no, it didn't. 2 and 2, so it's not true. So it's gonna loop again. The third element, it's gonna add it, and then it's gonna check if it exceed. Yes, it exceed. It's gonna pop, or it's gonna remove the bigger elements. Wait, oh, there is a problem here. So in the hip, how does the hip know which one is the bigger element? Because we give it a tuple that is x, y, distance. So hip by default check the first element. So in our case here, we're gonna compare with x. So we need to move this to the first, because we wanna, the priority is distance. So distance should be here. Okay, let's see. Let's see this code if it's gonna work. Run. Okay, you already write it. Do I need to import math or something?
For sure.
Wait, he said X. Oh, this is X. XY. Hip push. List object has no attribute hip push. Hip. How did you?
You have to do heap HQ. The first element is the heap name, and then the second element is the element you
okay,
want to push.
Hip Q, and then it's take two arguments. The element or the array where we're gonna push, which call hip, and then this, what the value we're gonna push. Okay. Oh, the same for this one. Hip Q, and then hip. Yeah. Let's run. Why wrong? Probably this math equation,
We're returning the distance for some reason.
which if I did like this, like the mid hat set,
Just check the solution there. You'll see that it's returning the Euclidean distance, I believe. Nope. What's that?
wait, I'm confused.
It's including the distance in the return. I don't know,
I
actually.
think I did some mistake here.
I have to remove the distance from the output, so maybe it's working fine. It just needs to return only the x and y values.
Oh, we can't return a hip like this. We need to loop through it. Yeah. And remove distance from output. Yeah, right. Okay. How we can remove? So now the array we're gonna return, it have this extra element. So it's like we're gonna create a new array. So how are we gonna do it? Okay, so we can do a for loop. Okay, let's create a new array. Results. And then we create a for loop. We're gonna loop on what? We're gonna loop on the hip. So for something in the hip. Now this hip have three elements: x, y, distance. Distance, right? Y, x, y. It have three elements, and I wanna push only the two. So I'm gonna do result. Push x, y. Then results. Okay, run. Oh, this should be at the end, not inside the for. Oh, result should be also here. What? What the problem?
Append?
Oh, there is no push. I think that's JavaScript. Wait, there is push? I don't remember anymore. Oh, it worked. Nice. Submit. Nice. Nice, 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 nice. Where is it? 50%.
Will you try without you square it?
Can you repeat? Without squirt? Like this?
Just to check if anything changes in performance.
Okay. Oh, that was 20%. Okay, let's check.
What magic is that?
So this solution,
Square root is hard one.
okay, run. This one is 4-3. Using hip replace with absolute hair. Okay, probably because a lot of functions. That's why it did go down. But if I try to understand it, you are pushing. You also did minus distance, and then you replace. I don't know why you use replace. If you wanna elaborate, what this mean? Hip replace. I'm not sure. This one.
You'll just need to change something there. It's not exactly 100%.
Okay. Okay, let's try to do the last LeetCode quickly. Where is it? Before that, is anyone have question about this LeetCode or the solution? So the key here is if you understand how the bytecode style, not pseudocode. If you understand pseudocode, how it works, or like the idea algorithm, it doesn't matter the language or like the hip, how it works. You can just code it any language. Now let's jump to the last LeetCode for this session. So we did 2. There's longest substring. We try to do it quickly, just so I don't take so much from your time, guys. But if someone wanna go sleep, it's okay. You can watch recording later. So longest substring without repeating character. Given a string S, find the length of the longest substring without repeating character. Okay, take this to the lab and let's see how we're gonna do this. So they give us ABC. Let me write it like this. ABC, BB, and we should return, what do you call it? Longest substring. Longest substring without repeating character. Okay. So E, B, C, A. Okay, A is repeating. So this is ABC, then ABC, okay, it is the same, and then BCB, okay, there is BCB, and then CBB, CBB, and then just return the 3. The longest is 3, they are all 3. Maybe if we did the brute force, we're gonna go through all of it. Okay, set. Using set. What you think if we did with the sliding window, like 2 pointer? One in the left, one in the right. So it will be something like this. Let's say ABC, AB. We do 1 pointer to the left, and one to the right, and then we keep moving with okay, let's ask first, is anyone have any idea? Wanna brainstorm? Because I have idea, but I wanna hear you first if you have something.
With the set. Oh, sorry, Saba.
It's okay, just go ahead.
With the set, we have to check its how to say, its occupancy. I don't know what else to call it. We have to check the fact that it's in, right, to make sure that it's actually not inside, to determine if it hasn't been repeated. However, if we use a dictionary, the lookup will be a lot quicker with it, not rather than having to go through the entire contents. We can simply check to see if the key actually exists in the dictionary, and if it does, we can then determine that there's occupancy at a constant time. That's the only consideration that I'd ask we make. But it can be done at the set and it can be done at the dictionary.
Wait, how
Yes,
does
Pakman.
it work with the set? Could you just explain it? Because the way I understand it
With
is
the set,
you just have to find like a section within the string that has non-repeating characters, and the set will just give you unique characters, right?
yeah, but before you add an element into the set, you check if it's already there. So as you're moving forward with the one pointer, you're going to be adding those things to the set but you check first to see if it's in the set, and if it's not in the set, you'll add it. But if it is in the set, it will mean that you have a repeating, and then which point you can count how many elements are in the set, and then you'd count the maximum as well as record where you started and where you ended, and then you would continue the whole process over again. And then when you find a repeating, you check to see first that the amount of elements in the set is greater than what it previously was. And if it is greater than what it previously was, it means that you found a longer substring of non-repeating characters. And then you record where you started from and then where you ended from, if that needs to be recorded. But essentially, you're moving and adding to the set if it's not already in the set. And if it's in the set, it would mean that you have a repeating character, and you'd have to record the start and end of those indexes and then continue the process over again. And if you find that the set that you have now with the characters is greater than the set that you had previously, that would mean that you found a longer substring of non-repeating characters. And then record and then keep on going.
Okay, I did understand like 70%. Sabah, also what you said something?
Yeah, I think my idea is pretty similar to Nyangasi's, except you don't record the start and the finish. You keep going, so you add A, B, C. When you get to A, you get your current length, and with the beloved max, you compare it with the, I guess, previous set. So I guess you compare the current length with the length of the set, and then I would remove the first A and then append the last A, and then you keep going.
Okay. This is using set.
Oh yeah, forgive me. I thought you had to return the substring. You don't, sorry. So you don't need to do that. I thought you did.
Okay, but your idea is same as Sabah. I guess we don't need to keep track of which one is the sub string.
Yeah, so
we can just
you go.
Yeah, go ahead.
Yeah, you add the elements, and then when you find a repeating, you record the length of the repeating, and then check to see if it's greater than the previous size of the set. The set obviously starts at how to say a number of 0, a length of 0, and then after that you'd have to clear the set and then keep on going. with a brand new fresh set. And then again, if that set is greater than the last set's length, you'd obviously change the max to that. But if it isn't, you disregard that one as well as clear the set again, and then keep on going.
Okay.
I don't know how much clear in the set will work for us. Because if you clear the set at the next A, then you just disregard in the first three. No?
That complex setting.
Ningas, your voice is cutting off. Can you repeat, Sabah? I didn't catch that.
Yes.
Okay. You back?
Yeah.
Okay, what can you repeat, Sabah?
Well, he said that after you encounter the first repeat, you clear the set and you start again. But
Okay.
You clear it all? Like everything?
that's what he
Okay,
said.
he's still cutting
It just came back, so it's gonna take second.
Say 1, 2, 3.
Sorry, the power
You don't
just came
clear
back.
the whole set. You clear only. You keep going
Duplicates.
until you
But yeah,
not there anymore. The duplicate.
point is valid. It doesn't really need to be cleared.
Okay, is you back, Ningase? 1, 2, 3. Okay, maybe he's not back yet. Okay, so we can. So
Yeah, can you hear me?
okay, you're back. Okay, repeat after me. 1, 2, 3.
3, 2, 1.
Okay, so we're good. Yeah. So we didn't hear an. Okay, he left. Oops. Okay, maybe he's gonna join again. Probably just network problem. So we all have 2-pointer. We said we're gonna do what we said. And what I understand is I kinda did the same solution you did, guys. So you go looping through each character and you add it to the set. So you're gonna add A, you're gonna add B, you're gonna add C. But the moment you're gonna find a character that is already exist in the set, what you're gonna do is you're gonna remove from the previous set from the left. So you're gonna remove this element, which means the left side of the first or the previous substring. So this you're gonna remove it. So you're gonna move this here because it's not including set. We remove it from here. Now we have just B and C. And then we keep moving. No, sorry. We add A to here, right? Now we keep moving. And why we have 2-pointer? Just to keep track the length of our substring. So we need to save it somewhere, right? So we need to create a variable. Let's call it results. Results. Okay, results. So first we're gonna have 0, 0, 0. And first loop we're gonna move to B. But we probably should add the first character, right? So A here. And then we're gonna move to B. We're gonna check, is it in the set? Okay, how do we let's write it maybe here. So we loop in for each character, and when we land on B we check if if exists in set. Okay, if it exists, I don't know what we're gonna do. Let's see it. So B, we're gonna, if it exists in set, we don't know so far what we're gonna do. If it doesn't exist, we're gonna add it to the set. So check if it exists in set, or just if exists in set, else add it to the set. Maybe we're gonna tweak the pseudo code. Okay, welcome back, Ningas. So we did not hear most of what you said, like in probably 2 minutes before you did the disappear. But I think we are in. We did hear you said that we don't need to clear all set. So we did go with the same idea, 2 pointer and set, and we're gonna clean only like a duplicate. So in this case we loop in on character B. Now B else, so it doesn't exist set, we add it, and then we need to update the result, right? Because the length now is 1, so this gonna be 1. But how are we gonna calculate it? Let's call this like a right, and this is left. So the results gonna be is R minus L plus 1. So this is how we're gonna calculate distance, and R in this case is index 0 minus index 1 plus 1 is 1. Okay, so now we tracking the result. Now we're gonna loop again.
0 plus 1 minus 1 is 0.
Probably did flip them. Yeah, I flipped right and left. So this is here, because the right is, maybe you should do the color. Left is purple and green is the right. Wait, it still doesn't make sense. So this is 1, right? 1 minus 0, 0, 1. 1 minus 0 is 0, so this is 2. Wait, how is this 2? Maybe the formula is wrong. R minus left. Is this 1? 1 minus 0 is minus 1. No, what is 1 minus 0? The hell? I can't think.
0 is 0. I mean 1, sorry.
1. I'm so confused. How is this equal 1? Can someone explain to me, please?
1 minus 0 is 1. 1 plus 1 is 1. I mean 2, sorry.
So R.
I mean, you have 2 elements in your set, A and B, so I think 2 is correct.
So, oh, it's not the length, it's the character, the 2 character.
Yes.
Yeah. Sorry guys, it was a long day. So 2. Oh my god. Oh, I need to cut this from recording so no one see it.
Impossible.
I'm joking. Okay, so we say 2 character. It was correct. It just I was expecting something that doesn't make sense. Now left. This is left, right. Okay, so we add this to B. Now we're gonna move. We update the result. We're gonna move to the next character. And then we're gonna do the same. Is it existed in the set? We still don't know what we're gonna do here. Else, add it to the set. So C. Update. We need to update, right? So add it to the set. And update result. Now we add it to set. We're gonna update the results. It's gonna be 0, 0, 0, minus 2, plus 1, so 3. We have 3 characters. Okay, now where we're gonna find the parts we don't know what we can do. So we're gonna loop. Gonna loop on A. Okay, so we're gonna loop to the next element A, and then we're gonna check if it existed in set. If it existed in set, we need to remove it from the set. But here's the problem. Here, they said we didn't check this key. So they said PW. Only do it here. They said something important that we miss, which is PWWKAW. The answer is WKE. So this is the most, or like the length of, or like this is substring, not the PWKE, because that is subsequence. Let me try to go through it together, see if we understand it. So in this case here, this is gonna be our substring P. Then we're gonna move to W. Then we're gonna move to W, and it's gonna be a duplicate. Now we can't jump to K and like remove this, like K and E, because substring, they should be, you can't remove the character, so they should be like a chain.
Continuous, yeah.
So if we did like this, it's gonna be subsequence, and for our case, we're looking for the substring and not substring. So
It's a loop within a loop.
yeah.
So you move your first pointer to the index of the first like duplicate.
Not necessarily. How to
Why not?
explain? You have to then see that this is the longest substring if you're beginning from the index of 0. Now you have to sort of kind of calculate the longest substring when you're starting from the next element, which is 1. And you have to keep on doing that because the duplicate for A, is essentially at the end, but it's not necessarily where it would always be, if you know what I mean. It could have been A, B, C, C, you know what I mean? And it wouldn't mean that the C is the C needs to, I mean, the A needs to be removed. It would mean that the C at the end would need to be removed. So essentially what we're doing is, and this might be flawed logic, but you're moving through the list one by one and then checking to see how far you can go from that particular element that you're starting with without finding a duplicate. And then you continue doing that until you you get to the end of the array. But essentially the duplicate may not be the first element in all cases. It may be that the duplicate is found at the end, like with the BBs at the end there. You don't necessarily know where the duplicate is coming from or where it would be positioned.
Let me try maybe do that in like visualization. for example, in this case, we have A. So it's like just a luck that we can just remove this, and there our substring gonna become BCA, right? But I think, what if A was here, or like let's say A was here. A was here and C was here, so we have C, B, A. So when we go C, B, A, and we find A again, if I remove just the first one, so I can't remove from the right, because we need a substring. That means they need to be connected. So I am forced to like delete from the left. So if I delete this from the left, is that fine? No, because it's still B, A, A, which this substring have duplicate. So I'm gonna remove again. Is it okay? No, it's still A, A. So I'm gonna remove again, and then we have A. This is valid. We can continue now exploring the next substring. So whenever we find a character that is existed in set, we're gonna keep removing all the elements from the left until there is no duplicate. So in some case, the duplicate is gonna be the first character, which is A, B. If let me redo this. In some case, the duplicate is gonna be the first character, which is gonna make it easy. Why? Because now I'm gonna say go to the set and remove duplicates. Okay, we're gonna go delete the first one. Is there more duplicates? No. Okay, so our string now, or substring, is BCA. It's unique. Does help? I hope that make it, or I did misunderstand. I'm not sure. Anyone can confirm? I think that's why we need to loop on each element in the set, which Ningas said we need a loop here. What do you think, Saba?
I agree with this, yes.
Did you had another idea?
No, not really. This is the idea I actually worked with, so.
Okay. Okay, so how the loop gonna work? The loop is gonna start and keep looping as long the duplicates exist in the set. So the loop gonna stop when there is no duplicate. So it means as long, which is while loop. So it's like while this condition keep looping, and the condition is while the character, well, let's call it character, in the set. While character in set. I probably should write code to. No, it's okay, we can convert it quickly. While the character in set, what you're gonna do, you're gonna go to the left character and delete it. But this is a set. We don't have index. We can't do like a set index 0 and delete it. We access the set with the like dictionary. We access it with we need the value. So we need this character A. So we can use the left pointer to get this value and then access it, look for it here, say like look for this value and duplicate. So we can do while character in set. Don't know how to remove. Is it remove something? Set remove. Set remove, and we're gonna do character, or we need string Yeah, this part's gonna be hard to write in pseudocode. But let's say this string is called s, so we're gonna do s, and let's say this pointer is left, we're gonna do left. So the pointer left is on 0, so the string index 0. So this way I get this value, and this set gonna go to this set and remove it. Now we remove it, we can loop again. But if we remove this from here, when we're gonna loop again, we need to access B, right? And the way we access B is through the left pointer. So this one also gonna move, because this is our new substring. So we need to increment the left. Left plus
I think you can use pop on the set and catch whatever that is popped and compare it with the character. So you have a while character doesn't equal the popped, and then you keep popping and catching that.
Okay, can do that. So while character in set, I'm gonna do pop here. Pop.
Even while character in set, you can initialize a variable called like popped, for example, and initialize it to none maybe. And
Okay.
then say like while character doesn't equal popped.
Okay, while
And then-
character doesn't equal.
So you catch the popped element, it's gonna pop from the left. It's not the same.
Okay.
So you're gonna catch it from the left, you're gonna pop from the left, you're gonna catch it and then keep comparing it to character. And the while loop breaks when you've popped the
But
the
isn't
duplicate in character.
But is pop gonna pop from the left or?
From the left, I've checked.
Okay, so we're gonna pop and compare. But isn't that gonna be some work? Because if we did like this, we don't need to compare.
I mean, you don't compare like the while loop compares, but sure, you can.
Wait, what you mean the while loop compare?
So while character doesn't equal popped, you don't compare inside the while.
Why? Okay, guide me through it because I am having some difficulty.
So initialize popped equal none before the while,
None.
and then while character doesn't equal pop.
While character does not equal pop, then we're gonna
Pop
do
equal set pop.
Pop equal
Set dot pop
that's pop.
in parentheses. Yeah.
Oh, okay, I see now. So while the character, this one is not equal to the one that's a pop, so in the beginning it's gonna be none. Wait, if it exists in set, then while the character is not equal to pop, I'm gonna pop, it's gonna remove A, and yeah, it's gonna put it in pop, so it's not gonna enter. If it's not A, it's gonna keep popping until. Okay, that's cool. That's really cool. Okay, if it exists in sets while character pop, we need to move this, right? Because our substring is not here anymore. But we need to move it each time we pop. So left plus plus, or like in Python +1, right? Because each character we remove it, the left's gonna just move because it needs to keep following the track of substring, because we need at some point to update the results using this length. Okay, in this case we remove A, we move the left, and and the while loop stop because in the set there is no more. In the set there is no more duplicate. What else? We need to update the results. Now it will be bad if we update here and then we update here. Maybe we should put this outside else. So both case we're gonna update anyway, and I think we're gonna add anyway. So let's remove this else because we're gonna add all the time, both cases. Either it exists in set or doesn't exist, we're gonna add this character. So here we're gonna add a. So what happened, we loop on a, we find that it's duplicate, we remove it, then when we remove it we move the pointer to the right, and then we add the character after we are sure now that there's no duplicate. We add it. Now we're gonna calculate the length, which is update result, and then we're gonna loop again. This is gonna move here. Do we need to reset the pop each time inside the loop?
Yes, directly before the while.
Like, oh, directly. Yeah, okay. So we need to reset the loop because what if it had some value before and it will not enter. Now we go to the next element, B. Now we're gonna check again. Orange, let's check. If it exists in set, yes it exists. What we're gonna do, we're gonna pop it from the left. Okay, let's pop this. And then we're gonna move this to the right. And we're gonna check again. Is there more duplicates? There is no more. Okay. Then it's gonna go to here, add it to the set. Okay, it's gonna add to the set. And then update the results. Update the results, which is still gonna be 3 length 3. And the results we said here, we're gonna use this formula R minus L plus 1. Okay, let's continue. So far it's working. Then we're gonna go to C. We're gonna go to C. Is it there duplicates? Yes, there is a C here. So we're gonna remove this, and then we're gonna check, is there more duplicate? No. We're gonna move this pointer here, and then we're gonna add C to here. Where is it? Okay. And then we add it, we're gonna loop again. No, I mean like when you add it to the hair, we're gonna calculate the length. It's gonna be still the same. And I think when we're gonna calculate the length, we're gonna check the max, because let's imagine at some point we have the length 1 or 2. We should still keep the maximum because that's what we're looking for, right? The longest substring without repeating character. So we need to use max here in update results using max. And then we update it, we're gonna loop again. B, is B exist in it? Yes, it exists. Okay, let's remove it. Okay, so we said we're gonna remove the first one left, and we're gonna move the left pointer, and we're gonna check again, is B still in the set? Yes, it's still in set. Okay, remove the left one. Move the pointer. And is B still in the set? No, it's not. Okay, continue. Add to the set. Okay, I'm gonna add B to the set. Update results using max. So this is 2 character. Now we're gonna do 2, or the results gonna do 2, but the results we're gonna keep it 3 because we're gonna compare 2, 3. We're gonna take 3. we're gonna loop again B. Let me remove this so it doesn't. We're gonna loop again to the right B. Now B, is it exist in the set? It does not exist. So we're not gonna enter this phase. We're gonna add it directly to the set and update the result using max, which is gonna be 2, but we're gonna choose 3 because it's the maximum. And this way we return 3. Okay, it's working perfect. Now let's convert to code. Who didn't understand something here in the simulation? I think it's clear, but if you have question, please don't hesitate. I might miss something or something because I already did this task, so I might go on some parts quickly than I supposed to be. So
Did you use the set as well?
yeah. Yes.
Cool.
Okay, so loop for each character. How are we gonna do that? Loop for each character. So for loop for each character, it's gonna be 4, I think. Is it 4? 4s. So character in S.
Oh, not char. Char is a preserved word, I think. No, am I talking nonsense?
Maybe it is. But if we do like this, we don't need index. I think we need index in left here. Okay, let's start from beginning. What is our code have? I have 2 pointer. Okay, let's put left. Let's put right, and have one variable result or result. So the results at the beginning gonna be 0, left's gonna be 0, and the right's gonna be 0. So we're gonna keep looping on string. I don't think we're gonna need index. Did we need index at some point? No, I don't think so. So just this, and then if character in set. Oh, we don't have set. What is set? Okay, set is set. So let's call it. What do we call it? Sub set. And then if the character inside the set, which is our case called sub, pop none, while character doesn't equal pop, you're gonna pop set, which is, we call it sub. We're gonna do pop, and then we're gonna increment left right here by 1, and then add it to the set. How are we gonna add character to set? Set is called sub. Push and character. Do you do push?
Push or append?
Append. I'm not sure.
Actually, it's add.
Add. Okay.
You.
Okay. Now update result using max. So result, we're gonna use max. So results compare with the new results, and we say we're gonna calculate the results with R minus L plus 1. So R minus L plus 1.
Right minus left plus 1.
Okay, left, right. And return results, I guess. Return.
Yeah.
Run! What happened?
You're not a incrementing right, I think.
Isn't right? Oh, this loop is supposed to increment right. So let's do for right. No, what? I'm saying?
Yeah, for write, comma car and enumerate us.
Enumerate. Or let's do the range, because enumerates take a lot of...
We have, because we were using car, so char.
No, we're gonna loop on string.
Yeah. But remember, we're taking element by element. So
Yeah.
we might as well use enumerate to get the index in the car in one go.
Or just manually increment it at the end.
Wait, but I think if we use write with the range, we don't need to increment it.
Then you're gonna change every car into like an S, right?
Like this.
But you're gonna change every instance of that car.
Oh,
This
Why does it
square
only have
bracket, right?
2, 3?
okay. I just want to have good performance in the code, so we can do like S R.
Isn't enumerate faster than range length S?
Yeah, I was thinking the same. Enumerate should
Really?
be faster than.
Okay, okay, my bad. Let's do it. Enumerate, and then S, and index gonna be
Right,
Right.
comma cha.
and ja. Okay, we are ready. What? I must be did something wrong. So this is the index, and this is f char. If character in the sub, you're gonna do while, you're gonna pop it, you're gonna increment it, and then you're gonna do sub at character, and then results gonna equal results right minus left plus 1. Okay, let's see what was wrong here. Expected tree, it gives 4. So this set did okay, let's take this string and let's apply the code on it. Let's see where's the error. I guess debugging is also a skill we need to learn. So let's go line by line and see where's the mistake. Okay, so we said results and we do left and right. Now for the right is red, if and we do set. Now if the character in sub it's not, so it's gonna add P, and if character it's gonna add it here, and then it's gonna put inside the result the max between the result and the right left plus 1, which in this case gonna be 1, because 0 minus 0 plus 1, both of them are pointing the same character there. So the results first time is 1, and then we're gonna loop again. W, it's gonna add it, it's not in the, so it's gonna add it because it's not gonna enter this app, and then it's gonna update the results, which gonna become 2, So I don't think we have problem here. We must have problem here. Let's figure it out. So we're gonna loop again. Okay, here's where error happened, I think. Now W is already in set, so if character in sub, pop none. Okay, pop is none, and then while character is different than pop, so character in this case is W, is different than none. Keep looping here. So I did pop sub pop, which it's supposed to pop from the left. Do we double check this just to make sure it's pop from the left? So sub and then set and then sub at 1. Can I do it like this? Print sub. I don't think I can. Maybe like that. But that's not the point. So let's say 1. Let's say we add 2, and then we're gonna pop. So it does pop from the left, so pop is not the problem. Now in pop we have P. Okay, so P it got removed. There we go. And then left plus 1. So the left move once right here. And then it check again. While it check if the character, which what happened to pop? Pop here become it's not N, it's become W. Oh, there's the error. Because we pop it, we need to clear it. What? There is a mistake here. So I think chat is not showing. So notice with me here when we no, I think I'm mistaken. What was the last value of pop? P? P. Yeah, so it's not, sorry. So P is gonna be, when we move to the left, we check again the while. The while gonna compare P. Sorry, it's gonna compare W with P this time, which is true. They are different, so it's gonna pop again. Let's pop this one. Okay, here is it. It's popped, and then it's gonna do left plus 1. Okay, here is it. Left plus 1. What else? It's gonna go to here. Sub add. Okay, here is it. It's added, and then it's gonna calculate the max between result and the right minus left plus 1. So the right minus left here is 0, 1, 2. So it's gonna be 2 minus 2 plus 1. So this one 0, it's gonna be 1. But we're having the max, so it's still gonna choose 2. In the example, okay, so the error is still not here. So it's still gonna choose 2 because we have the max. And then we're gonna loop again. We're gonna loop, the right gonna move to the next element. Now the next element, we're gonna check if it exists in there. It doesn't exist, so we're not gonna enter this loop. We're gonna add K directly. We're gonna update the results. The result is already 2, so this is gonna stay 2. We have 2 substring, and we're gonna loop again. When we're gonna loop, we're gonna move to A. Now A, it doesn't exist, so it's gonna add it, and here it's gonna update. It's gonna update the max, the results, so it's gonna become 3. And then we're gonna loop again. This time, okay, here where is the error happen. Here's where some point in our code there is a bug. Let's see where it is. Now when this go to the last character, somehow, wait, this said outputs it gives 4 and it's supposed to give 3. Now our code so far is working fine, it's given 3. Why when we move it become 4? Let's see why. Now we move to here. We did if the character in sub, yes it is. Okay, what's gonna do? You're gonna do pop none. Okay, pop gonna become none. Here is it. And you're gonna check character with pop. Okay, character we have W and we are comparing to with none. Okay, and now what you're gonna do is you're gonna pop the elements W. Okay, here is it, you pop it. And then you're gonna do left plus 1. Okay, here is it, left plus 1. And then you're gonna do yeah, so left plus 1, and then you're gonna check if the loop still gonna loop. If not, it's gonna stop because this character is not true anymore. Because when we pop W, the pop become W. But we are comparing now W with W. Here's the bug. So the loop is still gonna loop another time. Did you catch this, guys?
Yep.
So this condition is not working. Any thoughts, Sabah? Maybe I'm missing something. If it worked for you, maybe.
I mean, would you
Yeah,
kind of repeat the issue because I don't think I got it.
Okay, let me go back.
Yangasi, does your code work?
When we
Back
get to
to
the
the-
end of the iteration, we have a situation where we're comparing two similar characters. So it has W and W in the while condition. Does that make any sense?
I will repeat simulation from the last step so it's become clear. So we are in W key A, right? And then we move to here. We move to here. We move. Now we are in the new loop. We check this condition if the character in the sub. So W it exists here. So we enter here. Now we reset pop to none. Now here's our pop. We reset it to none. And then we're gonna enter the while loop. Now the while loop, we give it this condition. We said W, which is the character, which is the one that we're having the right pointer on it, as long as it's different from the pop, which pop in this case have none, as long as they are different, keep looping. Now in this case they are different, so it's gonna enter the loop. Now here's where what happened. When we're gonna pop the left element. In this case it is W. So we're gonna pop W. What that mean? That means this pop here, the new value is W, right? So we're gonna move the pointer one, the left one, but the loop is still gonna check if it's gonna stop or it's gonna do another loop using the character which is W and pop which is itself W. So the condition gonna be W is W.
Which is correct, I think, because it is the duplicate value. You remove it, you're left with KEW, which is 3, but they won't. No?
Wait. Okay, so something is...
Yeah, because you're saying W is not W, which is false, so it will jump out of the while loop.
Okay, but
Yeah,
what...
Which is correct.
Okay,
no?
I think I did mistake before then. Yeah, sorry. But what did I say before? I think I mistake this condition. Yeah, my bad. Okay, so far is great. If the bug is not here, let me just repeat it one time. Maybe I missed something. So while character which is W is W and different, yeah, so there is no bug here. It's just me. I need some sleep. It's okay. Okay, so it's stop here, but we have a new substring. So key, so we're gonna add the character W, and then we're gonna do result max, which is 3, right, left plus 1. Now let's calculate this right. Maybe it is the problem. Right, in this case it is 0, 1, 2, 3. So this is the left 3 plus 1, 4, 5 minus 3, 2 plus 1, 3. It is 3. Why it show 4? Okay, let's keep going. Maybe something happened. Okay, so for loop gonna stop here. There's no more, and then we're gonna return result. Oh, maybe what? From where?
Can you maybe add a print statement there with
Okay.
sub to see what it is?
Print here, and
Also print the sub, the set.
print sub. Wait, it worked. What?
Yeah, it works.
What happened?
Probably it was just a
Magic.
bug.
Come on.
Ningati, your
Wait,
code
no,
works.
it did not work.
Print statement.
Didn't-
Wrong.
It works in this, but it doesn't work in this. So, wait. What? 4 here. So it was WPK. Why didn't remove W? Wait. Okay. So P. What's the PW key? Let's take this to the. Let's see.
It
Yeah,
is the
this.
same example that we were working on.
Yeah, I just want to take this to here to compare. So P. So if we compare, it is P, and then we add W. Okay. We end end up with Q in the set. Somehow they end up with different sets. So P was here where I print sub here, it is P. Okay, we add first character, good. And then we print the results, it is 1. Okay, it's still good. 2, 2, 3, 4, 4, yeah. Now it was 3 is good. Now what happened? How this WEPK? WEPK. How is the order? Oh, is the set have different? Oh, the set have different order.
It
In the
doesn't.
set.
It didn't remove the P.
Yeah, no. In the set there is no order. So because we are using pop, this one, this pop, it's pop always the left side. But when you use a set and you add element to set, you don't guarantee the order. You know what I mean? So notice here the order is different. WEPK, like even if you add this manually, it will never be like that. WEPK. There is no such a thing, because we are popping, and in our mind is like that the set is gonna save the order. But I remember something about, does the set save order in Python? I don't know, or maybe the remove. No, Python as set does not preserve the order of elements. Sets are unordered collection of unique elements, meaning they do not guarantee that the order in which elements were added will be maintained. So the solution of pop will not work like this, because like this
Use
we
a
are
Q.
DQ.
Yeah.
DQ.
Pop left. And append.
What if we use array?
I mean, the time complexity is 01 for DQ.
Okay, import DQ. Okay, that was fun to find this bug. Import. I don't remember DQ.
No, fun isn't the word I would use.
I actually enjoy this, like this, when there's a bug and try to find it. It's so fun. Okay, DQ and maybe like this.
Your code work.
Pop.
I'm running it now.
Pop left.
So pop left and then append. Sub.append. Yeah.
Yeah, guys, his code passed, so I don't know what's happening.
I think I'm doing some problem here. DQ. How does it write? Oh, collection DQ. Or import DQ from collection, or from DQ import collection. From collection import DQ. Import DQ. Or I flip them.
Isn't it from collections.dq import dq?
From collection import DQ. Or import DQ from collection. Which one is correct? Oh, it worked, nice. Submit. Ooh, I did love this one. I don't care even if 12. It's okay, I will still clap. I don't know what was the error here. Like why it is 12, like that is too much. What if we use length? Length? Range? Just this. Because in my mind that enumerator take a lot, then So let's do air and then character. If character, so it's gonna be air and then air. And then air. And the right's gonna be just
air. Where did you get the car? Char.
car.
Yeah, where did you get it?
Oh,
It's
S, not A. You're right. S, which is the string. And we don't need. Maybe this print what caused.
Yes, it's the print.
Okay.
It slows it down.
Okay, let me paste this here temporarily and then. Remove this. Submit. Oh, okay. 50. Nice. Okay, let's go back, see this one. What do you think, guys? Gonna be more or less? I believe more. Come on, 60%? Okay, 60%. So I know it. Enumerates does it from performance.
You verify.
Okay, that was for tonight. Thank you for the 14 people that stay for like 3 hours. You guys crazy amazing. Thank you. I hope it was a nice session. I learned a lot. See you guys next session, and don't miss the session in Sunday. We have amazing session in Sunday. I keep it secret.
It's Saturday
Okay.
and Sunday.
Yeah, so the next session gonna be Saturday, right? And another one is gonna be in Sunday. Okay, here's the plan. So this one today, tomorrow, Saturday and Sunday. Yeah, just don't miss the Sunday session. There's a amazing thing. Okay, let's call it here. Thank you guys. I hope you enjoy it. Have a good night.
Peace.
Good night.
I'm gonna be filing for overtime.
You file for an overtime from the school, or is the other way around?
From the School of Nux.
Oh my
If the one supposed to be filing for the overtime.
Yeah.
Okay, good night, guys.
Today the boss overworked us.
Yeah.
Oh my god. Okay, have a good night. Bye.
Peace out, guys.
Peace.